Okay, everybody. Welcome to this week's lesson. Okay, in this lesson, it's going to be fairly, I think, simple. Okay, we're going to learn about the measures of central tendency. Okay, so throughout this lesson, we're going to look at the measures of central tendency. Okay, I'm going to explain what that is. And then we're going to learn how to find the mode, the median, the mean, the weighted average, trend mean. I think a lot of us learned about the basics of this in school, so now we're going to revisit all this stuff in the context of an actual statistics class. So it's going to be kind of cool. So what is central tendency? Well, central tendency is a measurement of how much the data has a tendency to go towards the center. Okay, so we're looking at how well the data likes to group together in one area and, towards the center of the data set. So, and of course, this kind of thing can only be used in quantitative data. You cannot do this in qualitative data, okay? So why do we even care? Why is this something that we even need to use in statistics? What does it really show us? So measures of central tendency are some of the most basic and also useful statistical functions that we use in statistics. So they can summarize your sample or population by a single typical value. Okay, the most common measures of central tendency that you do use in stats will be the median and the mean. Okay, so remember when we looked at distributions, that's kind of what we're talking about. Okay, we're trying to see exactly where most of the readings or most of the people in the sample are leaning towards. Okay, and that is why we use things like median, mean, mode, to try to figure out exactly where the data is mostly, if that kind of makes sense. So looking back at the whole distribution thing, it's kind of like that. Okay, as you can see in like these graphs, there is distribution here. This one is more of like a normal distribution. This one is a skewed right distribution, but we kind of get the idea. Okay, so the measures of central tendency, the main ones, right? Mode, mean, and median. Okay, so the mean, that is pretty much, that's the average. I think we already know that, okay? So when we look at mean, we're gonna look at what a mean is. We're gonna look at some fancy different things that we can do with the mean. Okay, so if there are a few little fancier ways that we can use the mean, and we call those trimmed mean and also the weighted average. I don't know why they decided to use the word average. It really means the same thing as mean, but we're gonna go through that. We're also gonna go through the median and how you can find your median. And I want to let you know that there's two different ways that that you can find the median, and it really just depends on whether or not you have an odd number of values or even number of values. Okay, so we're going to look in and see. It's just a little bit different about how you calculate that, and of course the mode, but the mode is not going to be that difficult for us. Okay, so mode. Let's start with mode. This is probably the easiest and the most, well, we'll see. Let me show you. Okay, so mode. Mode is the value that occurs most frequently in the data set. Okay, so in this situation, if these were all the data points that we had, the data set that we had, obviously the 5 would be the mode, right? because that is the one value that occurs most frequently in this data set of 5 numbers. But what if we change the 5 to a 6? Now we have no mode, okay? And that can happen. Sometimes you have no mode. So in this case, we have no mode. Now look, now we have more data and we have 2 2s and 2 3s. So what about this situation? Yeah, sometimes we have more than one mode. You know, if we have several different datas or several different values that both occur an even amount of times in your data set, then you may have 2 different modes. We can even have 3 modes. You know, if we had like 2 6s here, that would also be the case. We would just have 3 modes. Mode can get confusing a little bit when you have a lot of numbers, okay? So it's something that you just have to pay attention to. But it's the value that has the most, or that occurs most frequently, okay? So, you know, what you would do is just go through, and anytime you see any number that is repeated throughout the data set, you would just kind of make a mark on that. Like if we were going to go through here, we would see that there are 2 2s. Okay, make a mark next to that. We got 3 3s here. We have another 3, another 3, a 3, a 3, right? And with our 2s, we got 2 2, 2 2, 2 2, like that, right? And I mean, I'm not going to go through and go check all the other numbers because I see that we definitely have more 5s, we got some 9s, we got some anything. We have, you know, several of different, we have several different values that occur numerous times in this data set. We can see that. So what you would do is just kind of go through all of them, and then you figure out which one actually wins, which one has the most, which one happens the most. So who knows, what if that was the 9 or the 5 in here in this data set where it occurs the most times? You know, that basically it's the one that wins, you know? And if you have 2 or 3 modes, that's also okay. So sometimes you do, especially in healthcare, sometimes you're going to have patients that might have the same readings. You know, it just happens that way. It doesn't necessarily actually even mean anything. That's why in healthcare, you don't really use mode very often. We don't see people doing research with mode because what does that really mean? If you know, 3 people have the exact same blood pressure reading in a data set, it doesn't really, it's not too significant. I don't know what that really tells you, just because that happens just by coincidence. Now, if they stay within a range, that's one thing, you know, and then you have people who are high and people who are, you know, too low, and then you have those who are staying within like a certain normal range. That would be, that's one thing, but mode would not tell us much in that type of a situation. And so in many situations in healthcare, mode doesn't really help, okay? But I mean, if you're going to use mode in your data set, it's up to you. You have to know like what you are actually trying to find, okay? And if mode is going to be useful for you, if it does really tell you something about the data, knowing like which value occurs the most, then you need to use mode, of course. But typically in healthcare, that's not something that is usually necessary to use. Just putting it out there. But what does the mode really tell you? It doesn't tell you much. It really just tells you the most popular or the most common answer or the most common data value. That's all it tells you. And so we don't use it so much in healthcare. Other industries, of course, I think there are definitely reasons to use that, okay, especially in marketing, but not so much in healthcare. So the median is the center of the data. If you didn't already know before, yeah, that is the center of the data. It's very, very simple. So every quantitative set of data can be sorted in order from lowest to highest, okay? And so since you can do that, you can actually, put your data, your numbers, since they are numerical, you can put them all in order from lowest to highest. So, and then, even though maybe in your data set there are going to be repeats, okay, there usually are repeats, or, it's definitely possible, and it doesn't really matter if you have 5 5s in your data, and then just put those 5 5s there. Just line them up, in order from lowest to highest. Sometimes you're going to have outliers. Sometimes you might have, all your data where it's all kind of like 1 through 5, and then you have a 17 in there. That's fine. Still put them in order. So sometimes all your data values are almost the same, and that is also fine. You might have 1 through 5, and every single, most of your data values will all be 4s and 5s or something. That's okay. Just put them in order from lowest to highest, and then after they are arranged in their order, the median is the number that is just that halfway mark. Okay, just the middle one. So I'll go ahead and demonstrate that in the next slide. Okay, now we're gonna look or figure out how to find the median. Okay, so first of all, order your data from smallest to largest. So I already did that for you guys. I took 2 different data sets, this data set, and then this one, and I ordered them from smallest to largest. Okay, and that is what I did here. I'm just trying to show you guys that I put them in order. And I actually ordered the order by writing them 1, 2, 3, 4, 5, aligning them with whatever order number that they are. So you can do that, and I think it's way easier if you write it out like that. So if you put all your numbers, your data values in order, okay, smallest to biggest, and then go ahead and if it helps you, I would number them. Okay, number them like I did here. Just number each value. Okay, so that it kind of it makes it a whole lot easier, because look, remember I said that the median, the way you find a median is going to be a little bit different if you have an odd set of numbers and an even set of numbers. Okay, so this is the odd set of numbers. If you have an odd set of numbers, okay, then it's so easy. After you've already numbered them, you can tell that the third number is going to be the middle number, right? Right? Yeah, it is. So 42 is your median for this one. Okay, 42 is the median there. But let's look at the data set below. Let's look at this example. So I already numbered them, okay. I put them in order from smallest to biggest here, and then I numbered them so that we don't get confused, so we know which number is what, or which number goes where. And this is an even set of numbers. Okay, we have 6 numbers here. Over here we had 5 numbers. Here we have 6. So we would know that the middle is between 3 and 4, right? Okay, so what we're going to do here is we're going to take 7 and 8 and we're going to add them, okay, which is 15. and then we're going to divide by 2 because we're taking the average between the two. Okay, so we're going to divide that by 2. And then what do we get? 7.5, right? So 7.5 is your actual median for this data set. Okay, that is the middle number, or the very middle of this data set. So that's the difference between finding the median between odd numbers of data sets and then even. Okay, if you're taking an even number, you have to do a little bit more work. You're going to have to find the average between the two middle numbers. But if you have an odd set of numbers, it's super easy. You just take the very middle number, which was 42 in this case. But oh my gosh, what if we have a data set with a ton of numbers? Oh no, what are we going to do? Do we literally have to count each one up? That's going to be a pain. Well, there's a formula for that, okay? So let's say that you have a data set where there are 21 values in that data set. That's not going to be fun to have to order. It's not going to be fun to have to like put together in an order and then just start counting and you just focus on which one is the even number. How can we shorten that process? Well, okay. First of all, you still have to have your data values, your data set to be ordered from small to biggest. Okay, so this is still something you have to do. Now, do you always have to do it by hand? No, you don't. There are plenty of softwares out there that will do that for you. Excel can do that for you as well. There are other things you can do. So you can get it ordered for you after you just put in your data set. If you don't want to spend the time to write it all out, that's cool. So anyway, what is the formula to actually find the median? Well, let's say we have 21 values in our data set. Okay, so the formula here, how do you find which one is going to be the number, is you're going to take n, which is your however many values are in the data set. You're going to, well, here's the formula, right? And then you divide it by 2. So you're going to take that, you're going to add 1, okay, and then that will give you 22. Then you're going to divide that by 2 because, of course, when you find the middle number, we're finding that halfway point, basically. Okay, so you want to cut it in half. We take the, so you're going to take your data, the amount of values you have, add 1 to it, and then divide by 2. What do you get? In this situation, we have 11. That means that if you were starting from the very beginning of your data set, okay, after you've already numbered them, they're already in order, right? The 11th value, okay, the 11th value is going to be your median. So you would just start from the beginning and just count up to 11, and whatever number it lands on, that is your median. Okay, I hope that makes sense. Let me see if I can try to demonstrate that in a smaller version. Well, basically, like what if, all right, let's pretend that we're doing one where we're n equals 5, okay? And, all right, so we put our values together. Okay, so these are our values. Let's say I ordered them all together and I'm going, what's the median? How do I know? And you want to use this formula for a small data set. You can also do it for that, but I just feel like it's very obvious when you look at just a small little data set like this. You don't need to do the formula, but you can, okay? So let's say our n is 5 because we have, 5 values here. So n is 5 in this situation. So using the formula, we would go 5 plus 1, which is 6, and then we're going to divide that by 2. That's 3. So that means the third value is going to be our median. What's the third value here? Well, we go 1, 2, 3. this would be your median. Okay, so that is how this whole situation works, but it's imagine doing this on a larger scale is what I'm trying to say. Now, how do we find the middle number or the median if you have an even number of values? Okay, well, you're using the exact same formula. Okay, in this situation, spoiler alert, same exact formula. You're going to take n, okay, you're going to add 1, and then you divide it by 2. And whatever this value is, well, then what you're going to do, there's a little bit more work after this. Okay, so let's say you have all your values, okay, all lined up in order. All right, just pretend these are values. Then you're going to take whatever you got from your formula, okay, and go ahead and start working your way up. So you go 1, 2, 3, 4, 5, 6, 7, okay, and it says 7.5, so you're somewhere in between, right? So, and then here's your 8th value. What you're going to do is, this is telling you that it's going, your median is somewhere in between the 7 and the 8th value in your data set, okay? So what you'll have to do is take those two values and then find the average. Okay, so you're going to take those two values, add them up and divide them by 2, just like how we did in the simpler version of finding the median with an even number of data sets. Okay, it's the same process, except this is telling you how many numbers you got to go up from the beginning. Okay, and since it's a 0.5, and usually, I mean, especially in even number data sets, you're going to probably get a decimal. So, and like I said, what that really means is that you're just going to go up to that value, and you know that the actual median is somewhere in between, and so it's going to be an average of those two values. Okay. Okay, so what does the median even tell you? Well, the median is the middle rank of the data. Okay, the median, the really cool thing about the median is that it's very resistant and it's very stable. Okay, for example, it does, like what if I decided, or like, okay, let's use this as an example. Going or taking a quiz in this class, okay? Now, what if I offered extra credits, like a lot of extra credit, but only like 3 people took advantage of that extra credit, so they got ridiculously high scores, and then you probably have a couple people who decided not to even take the quiz, so they get 0s, and then you have the rest of the class who is somewhere probably in the middle, okay? The thing is about the median is it doesn't, you can't like knock it out of place, you can't wobble it, you can't make the median, if we have a couple zeros on one end and we have a couple really high scores, okay, those are outliers, right? Those outliers are not going to bother the median at all. The median is probably not going to change at all. You know, if you have those outliers, the median is just the middle number. It's like where all the action is, okay, where everyone's sitting and where most of the scores are, most of the values are hanging around where the median is. Okay, usually that is the case. So that is why the median is pretty important. It can tell you some things about what is actually happening and where the action really is in your data, depending on what you're trying to find. And the outliers don't mess with it. So, okay, so real quick before we actually get into the mean, okay, I just want to make sure that you guys are all aware of what this sign, this symbol is and what it means. So this is the Greek letter capital sigma. Okay, that's what it's called. It's capital sigma. So anyway, whenever you see this or this, I mean, these are just different fonts. It's the same thing. But whenever you see it in your head, you should automatically think that this means sum of something, sum of whatever, okay? Because that's all this means. This means you just have to add up whatever it's telling you to add up, okay? So for example, sometimes you might see this, right? And then x, y. What does that mean? It just means sum of x, y. So you would have to add up that. Okay, well, yeah. That means you have to, you have a bunch of x and y's and you need to add them up. Okay, it could also mean some, or just sum of whatever. Okay, anytime something is next to this symbol, it means you got to add it up. Okay, so that's really all that means. Don't get afraid of this symbol at all. Okay, just get used to thinking every time you see that, add stuff up, whatever's next to it. Okay, it's just telling you which math problem to do, pretty much. Okay, now let's put it together for the mean. All right, so basically right here, this is the formula for the mean. We have that one Greek symbol, okay, capital sigma, x over n. So what does this mean? Well, the x's are all the data value points, right? Or the data values. So your list of data. Let's pretend we have a data set and these are the values, okay? So that's all x is. Just your data values. And then your n is how many data values there are. Okay, so n is the number of data values in your data. So in this situation, this is our data set, right? And n would be 6 because we have 6 different data values. Okay, and so in order for us to use this formula to find the mean, we're going to add up all these, okay? And that comes out to 40. And then we're going to divide that by 6. Okay, and then we get 6.7. So that's all that is. Now our mean is 6.7. All right, here are some more symbols about means that I want you guys to, or actually it's very important for you guys to know. Okay, so when we're doing statistics and you're looking at means and things like that, there are two main different categories, if you will, categories of symbols, I guess I would put it that way, of symbols that you need to be looking out for, and that's going to tell you of whether or not you're dealing with a sample statistic or a population. Like, did the study or whoever conducted this, whoever put this information out there, did they do a population kind of study? Did they take census of the population there? Is that where they're getting their information, or did they use a sample? Okay, because depending on whether or not which side you went, you're going to be dealing with different symbols. And when you're trying to read through what other people have done, in their studies and statistics and whatnot, you might get confused if you don't understand the notation. Okay, so let's look at sample statistics because this is probably the most common. So many times you'll see this. Okay, this is called X bar. And X bar basically means the mean. That is a symbol of the mean, okay, in sample statistics. So someone did if someone did a study where they used a sample, they did not take census, they're not checking information about the population, they did a sample, then they would use this symbol as their mean. So see, remember this equals the mean, this formula right here. Well, so does this symbol. Okay, this symbol equals the formula for the mean. You can also go, hey, if your mean was 5, you can literally write it like this, and then everyone would know, oh, okay, the average, okay, for that sample size, the sample that they did was 5. Okay, if you wrote that, everyone would read that as, that. Now let's look at Population parameters. Okay, so if we're dealing with that, the notation that you're going to be using for the mean will be this symbol over here, and it's called mu. Okay, so these both are the same thing. They're just different fonts. Okay, so just kind of get an idea of what it looks like. But yeah, this is called mu, and mu literally looks exactly, this is the formula, of course, for the mean. So that's all that really is. When you see this, you go, okay, they're talking about a mean for population parameters. That's where they must have got all their data by surveying all the people that live in that area. Okay, and also another thing that you should know is the n in this type of formula. Okay, this is population size. It's really the same thing as it would be in this formula. Okay, and the other one, the one per sample, it pretty much means the exact same thing. The only difference is you are using this type of notation for population parameters, and that is why, when we are using it for this, we're going to use a capital N. Okay, so just a few things you need to be mindful of when you are doing problems, or when you get out and you conduct your own studies. You need to have proper notation, because people who are reading your study, when you finally write everything out, they're going to notice these things. Okay, and you might throw them off, because if everyone's speaking the language of statistics, and we're looking, if we are looking at the fact that you took data from a population and you got your mu here, but then we see lowercase n's everywhere, we're going to get confused. Okay, so you gotta know some of these symbols and what they mean and what they indicate when you are reading data. Okay. Okay, so remember when we were talking about medians and we were going, wow, they're just so resistant and so stable to the outliers. Like if we had a whole data set, and then we had like a couple okay, here, let me show you something. So let's say if we go back and use that example of the quiz, maybe most of the quiz scores were all around here in the middle, right? And then we had like a couple of people who had zeros, and then you got like a couple of people who did all the extra credit, and it was like a lot of extra credit, so they all got like really, really good scores, and they were all down here. Well, if we took the median would still be over here somewhere. And so the median is pretty resistant to outliers. The median still shows us what's going on where the action is, right? Well, it's not like that with means, because if we used a mean for the class average of the quiz, right, and we took in consideration these outliers, so of course we're going to include the outliers, we will include some the students who got like really high scores, and then the students who got zeros, and then include that in with like the rest of the class, and then basically that would really throw off the mean, right? It would change the mean up so much. Okay, that would definitely affect the mean. The mean would probably be a lot higher. The mean might be somewhere around here instead of over here where all the action is, where most of the scores are. Okay, the mean might come out to be over here, and that's like nowhere near any of the other scores. So things like that can happen. So what do you do? How do you make the mean more legit for your data? Okay, so if we have that issue where we feel like, all right, we have some really high or really low values that are outliers, and they're really throwing off the mean, and we don't want it to be a problem in our data. So what we can do is we can trim the data. Okay, we can trim data off each end of the data, so that we can get the outliers kind of cut out from the mean, and then that way it can be a little bit more fair, and we can take the mean of what we have left after we've already trimmed certain outliers out. Okay, so typically you probably want to do like a 5% trimmed mean. That's pretty normal. Okay. So how you would do this is you figure out how many data points you have. Okay, let's pretend you have 100 data points, like 100 data like values. Okay, 100 numbers there. And so like if you want to do a 5% trimmed mean, what is 5% of 100 points? Well, 5% of 100 data points would be 5 points, right? Just 5. So you're going to take off 5 points, okay, 5%. So what you're going to do, you put all your data in order, okay, from lowest to highest, okay, the lowest values, and then put all your data in order. You can use any software to do this, especially if you have 100 data points. That's a lot, okay. And then you have your high values, your highest values. So low to high, go ahead and number everything, just like how you would do for a median. We're going to go ahead and do that here with the mean. All right, so we put all the data in order. Now we're going to remove 5% from the top and then 5% from the bottom, since we figured out that in this case 5% would be 5 data points. So we're just going to take off the top 5 points, shave them off, take them out, and then maybe the top 5 or the bottom 5 points here. Get rid of those numbers, and then you take the mean of everything that's left. Okay, that is how you will do the trimmed mean. And of course, if you do a trimmed mean, you have to say it and you have to explain why. Okay, so you got to tell the in any kind of study that you're doing, if you have to do trimmed mean, you need to explain why you feel that those outliers should not be included in the mean, why it's throwing it off, whatever. And then you need to explain exactly what you did. So you took a 5% trimmed mean, which means and then you decided that, okay, or you calculated that 5% of the data points, since you have, you took however many data points it is, you took figured out how many points it would be for 5%, okay? And then, depending on however many points that comes out to 5%, okay, you're going to take 5% from the top. You're, cross those values out from the top, and you're going to cross them out from the bottom, and you're not going to use them in your mean anymore. They don't count. And then, in the end, you just take your mean like you normally would. So just the average, you're just going to add everybody else up and then divide by how many values there are. Okay? It's actually very simple. All right, now we're looking at weighted average. So this one is a little bit more complicated, I will admit to that. So anyway, why do we use weighted average? What is the weighted average for anyway? Well, sometimes when you're doing statistics and you're looking at your data and then you'll go, you know what? Some of this data is actually more important than other parts of the values that I just got. Or maybe you realize that there are certain data values in your set that are worth a greater portion or hold a greater value than others, and some others might be worth a little bit less. And normally we see this mostly in school. Okay, I'm admitting that in real life I don't even know if I have really used this so much. So you probably won't see it in real life, but you do need, or you might. But it's really great to understand this and to know that it's there if you need it, especially if there are any studies that you will be conducting later on where you need to do this. This is a possibility. You can take an average and put more weight on certain values than others. Okay, so if you're ever in a situation where you need to do that, great, you know how to do it now. So anyways, let me give you an example, because I see this in school all the time. Like, you know how sometimes your homework, you'll see on the syllabus where your homework is weighed like 10% of your grade, and then your quizzes are 20%, and then there's like your final exam will be worth 70% of your grade. So like, what if you get an A on your homework and then you get a B+ on your quizzes, and then you just get a B on the final exam. Well, if you were taking an average of all three of these scores, right, your average would actually just, if it's a non-weighted average, it would come out to a 3.5. So that would be good. You'd be like, wow, I got a B+ overall. I'm great. But you're not taking into consideration the fact that each one of these different portions of your grade are worth different, they're weighted differently. So your final exam is actually worth you can't take an average of each of these scores and allow them to just be equal. Like this, take the mean of each of these values on an equal playing field, because they're not weighted equally. Okay, so that wouldn't be your actual grade. What your actual grade would be this one. Now, how do you find the weighted average, where you include the different percentages of, what each portion is of your grade, or what each value is, like how weighted each value is? Well, you would use this as your formula. Okay, so you know what this symbol is, the sigma, right? That's sum of. Okay, and then X, these are your values. What is W? That is the weight, or the percentage. Okay, so what this is going to look like when you're actually, when we use this example of using like grades, okay, scores for your homework, your quiz, your final exam, and taking the weighted average of that. How we would do that is, first let's start doing this. All right, so the first one, your homework grade, that your score on that one was a 4, right? And then for your all right, so you got a 4 on that one, and the weight of your homework is 10%. So that one is going to be multiplied by 0.1, right? 0.1. Plus, all right, your next score is going to be what? We got your next score at 3.5, because that's your quiz grade, and your quizzes are weighted at 20%, which is 0.2. So we got 3.5 times 0.2. Okay, and then next we got your final exam grade, which is 3, and the weight for that one is 70%, which is 0.7, right? So plus 3 times 0.7, all right? Well, I already did the math for that right here. So what that is going to come out to is, well, hang on, let me go ahead and calculate that. Because then we are going to go ahead and divide it by the total weight, which is 100%, right? Or 1. Since the total weight is all of these percentages, right? So 70 plus 20 plus 10, that's going to be 100%. Okay, so which is, 1. So basically what you're going to do is take all of this and divide that by 1, which is going to give you, one second, yep, I got 3.2. Yep. And then, of course, divided by 1. Yeah, okay, my math is correct. I'm sorry. So yeah, if you do all that, you should be able to get 3.2. So 3.2 was the actual grade with the, with all the weighted proportions. Okay, so that would be your weighted average. Okay, so you can see there's a big difference between just, getting good scores on homework and quizzes versus getting, a good score on your final exam. The final exam in this case is worth more than anything, and it's weighted heavily. So, since unfortunately this student, the lowest score was the final exam. So that is what brought their weighted average down from what they thought it would be. But that's pretty much how it works. All right, so now let's look at the measures of central tendency and where they fall on a graph when we look at the distribution. Okay, so this example right here is going to show you what it looks like with normal distribution. Remember, normal distribution is something like that, right? Well, I did a bad job at drawing that, but you know the idea. So anyway, in this example, I kind of color-coded the mean, median, and mode just to show you where they fall on a graph like this. Okay, so we have normal distribution here. As you can see, the mean is right here. It's this one, blue, and the mean is blue, right? And it's like, and then you have your median, which is the green one, and it's like right there, and then you have your mode, which is the purple one, and it's right there, right? And if you look at this, you can see that the mean, median, and mode, they're all pretty much on top of each other. They're all towards the very center of the graph, okay? So, and normally, if you see median, mean, and mode, and they're all kind of gravitating towards like the middle of the data, then you know that your graph, you just automatically should know that this is going to be normal distribution. Okay, so your graph is just, it's definitely going to look like this. Okay, because the mean, median, mode, they're all pretty much on top of each other. They all kind of look the same and all that. But what happens when you have skewed distributions? Well, as you can see, the mean, median, mode, they're still color-coded in the same way on this graph. So, and this is the top one is a skewed right? Because remember the bottom, this part, the skewed part, I guess, is the skewed right is where like the lower values are on the right side, and then skewed left would be where the lower values are on the left side. Okay, so anyway, we got that out of the way. Remember how these distributions are. So now let's look and see what the mean and median and mode are doing. So if you can look at the mean, okay, the mean is right here, and it's right here in this section. So whenever you have like a skewed distribution, you're going to see that the mean is going to be gravitating kind of like towards the end of the action, but it's going to be closer to wherever like the smaller values are. Okay, so if you, or the small, not necessarily smaller values, but like the small amounts of values, because these are obviously higher values. So you would know that if you were just looking at data and you saw that the mean, if you looked at all the central tendency measures, right, and you looked at your mean and you saw that the mean is a little bit higher than the other two, okay, and your mean seems to be like it's skewing a little bit towards the higher values, then more than likely you can already guess that this is going to be a skewed right distribution. Okay, also if you noticed, so, and then you know that your median is always going to be your median's not really going to change. Your median is just going to be the median. Okay, it's the middle number. Because it has resistance, it really doesn't, depending on, the outliers don't really have anything to do with the median. It doesn't affect it at all, but the mean of course, gets affected. So the mean will be hanging around, and it'll be leaning towards the area where there are a lot of maybe higher value outliers. And if there are higher value outliers, then you know that it's probably going to be a skewed right distribution, right? Same thing with it's like the opposite is true with the skewed left distribution. Okay, so you'll see that after you found your median, your mean, and your mode, your median is just going to be whatever the middle number is, and it doesn't really get affected at all by any kind of outliers, but you know that the mean, okay, right here, the mean is leaning towards your lower values over here. All right, so it's away, it's not on top of the median like how it would be in normal distribution. They're all kind of like the same value. Well, the mean is now lower than the median, and since it's leaning more towards the lower values, then we can only assume that this is definitely going to be a left skewed distribution. Okay, so that is kind of the difference. You can, just by looking at your mean, median, mode, and looking at the values, you know, if your mean seems to be it's a lot higher than the median, you know, that means it would be more over here on the graph, or here. It's not, if your mean is not equivalent to the median, or it's not lying on top of the median, then you know that it's probably going to be right skewed distribution. If your mean is lower than your median, then it's probably going to be your left skewed distribution. Okay, and your mode is just wherever the most values are. So if you see in here on this in this area where the mode is like in between the 1 and the 2, this is probably you could probably guess that since it's like a in between those two values, maybe that is where well, your mode, you probably have a lot of numbers in this value, in this area, or a lot of value, yeah, sorry, a lot of values in this area. And if you actually look at this, you can kind of go, oh yeah, there's slightly more ones than anything else, so it's probably lying around here. Same thing with over here, your mode is about right here, and it is definitely a little bit slightly higher than the 6, and of course higher than everywhere else. So your mode is just going to hang around wherever you have a lot of repeat values. And usually when you have a lot of repeat values, the repeat values are usually where you have you know, a lot of your where a lot of the action is anyway. Okay, because if you're going to have a lot of repeat values, then those values must be really common. So yeah, they usually are sitting around wherever the action is over there. So I hope that this lesson helped you guys, that you guys get a much better understanding of central tendency and all of this. And I will see you guys in the next lesson. If you have any questions, please let me know. Other than that, happy studying.